Today we want to talk about something called cis-trans isomers. We've discussed isomers before. We know that isomers are molecules that have the same formula. They just have different structures. Well, in this case, when we're dealing with alkenes, it takes on a little bit different meaning because alkenes are not like alkanes when it comes to how the bond can rotate. Take, for instance, if we had a alkane that had 2 carbons, and around those carbons we had a hydrogen, a bromine, and a chlorine around this left-hand carbon. Imagine these carbons being styrofoam balls that you just have a stick stuck into, attaching the 2 carbons together. Think about the fact that because it's just a single bond, and the model works perfectly with that stick, we can rotate these around and we can just spin those around. It's kind of hard to see whenever you can't see the motion and you can't see me with some 3D object, but that carbon can rotate, and that hydrogen, the bromine, the chlorine, they can spin around. So I could just as easily write it like this with the bromine on top, the hydrogen here, the chlorine here, or perhaps like this with the chlorine on the side, the hydrogen on the bottom, the bromine on the top. It doesn't matter how it's written. They're all the same compound because, again, that bond is free to rotate. Now, on the other hand, imagine that we've got a styrofoam ball, 2 of them, and we've got these 2 carbons here. This time we attach 2 sticks between them. And hopefully you can see that if we do that, that chlorine and hydrogen attached on each side will not rotate. They are stuck in that position. Since they cannot rotate, this structure and this structure are different structures. If we put in, just to emphasize this, if this were just a single bond in between, if this were one single bond, then these 2 would be identical structures because the rotation wouldn't matter. But it matters very much when there's a single bond there. So they act differently, they do different things, so we have to think about them in terms of 2 different kinds of names. And the way that we name them is with prefixes. This cis prefix and this trans prefix are the ones we use to show what's happening to the parts of the molecule that are not hydrogens. The hydrogens don't count, so we're just looking at where the chlorines are. It's always what's in here other than hydrogen. Notice that on this side, the cis side, and I always used to remember it this way, same side. Same side. On the second structure, notice that the chlorines are opposite sides. And because they're on opposite sides, we call them trans. I think of across the Atlantic. They're across from each other, transatlantic, across the Atlantic. So that's how we name them. So let's look at somewhere where this has been getting a lot of news in the last few years. Trans fats. Normal fats and oils are cis fats and oils. They have all of their structures are on the same side. They act differently in the body than the trans ones. Look what happens here. Those non-hydrogen groups are on opposite sides of the carbon. That makes the fats last longer. They have a longer shelf life, but they do bad things in the body. They're called trans fats, and according to our new regulations, we shouldn't have any of those. They're very bad for the body. So that's where they get that term trans fats. It's from the cis-trans nomenclature. So if we look at this molecule, can this molecule exist as a cis-trans isomer? And the answer to that is no, it cannot. In order for it to be cis or trans, it has to be on the same side of, not the same carbon, they have to be on two different carbons. So the CH3 would have to be one on this carbon, and either in this position or this position on the other carbon in order for this to be able to be a cis-trans isomer. So this is no, it is not. So if we're naming these, we simply count the way we always have. We start numbering from the carbon closest to the double bond. So we'd start numbering from here. So it looks like this is a pentene. However, since this one has the non-hydrogen groups across from each other, this would be trans. It's written in italics, but in handwriting they usually underline that trans part. Trans 2-pentene. And this one, since the non-hydrogen groups are on the same side of the two carbons, it's still the pentene, but this time it's going to be cis 2-pentene. And that's the difference between cis and trans isomers.